Okay, today we're going to look at ice melting. Okay, so I don't know if you remember, but before the holiday, before half term, we looked at these ice houses, okay, or we looked at refrigeration and looked at how houses didn't have fridges and people used to buy ice to keep food fresh and to have cold drinks and things like that. And I don't know if you remember this picture, but these are ladies in the 1916 that's delivering ice to people's houses, and they're loading it off the cart and they're carrying it to people's houses to be used. So they're selling ice. Now they need to make sure that this ice doesn't melt, because if it melts, then obviously they can't sell it. Okay, and it's a little bit what our experiment is today. What our experiment for today is. So if we look here, ice delivery people had to make sure their ice didn't melt. How could you stop an ice cube melting, or how could you see if your idea worked? So what we're going to do today is use some materials to see which material will help ice not to melt, okay, or to slow down ice melting. And now before we move on, I just thought I'd show you, if you're interested, especially if you're interested in history, and I am, and I love old photos. And I came across this photo, which is, strange enough, obviously the one that I showed you a while back. And I came across this yesterday, and it is the same photo and it's in color, so it's really, really well done. I really do like this. So if you like your photos or photos from history, or mum and dad does, you might ask them on Instagram. There's this page called History from Every Day, and some really, really good pictures on there. And most of them have been colored, and they just look quite realistic. They look like, you know, it was taken a couple of days ago. So it's really nice effect. Anyway, let's get started. So today is the 5th of March. The experiment we're going to do today is how can we slow down ice melting? Okay, or how can we stop it? We can't really stop it completely, but we can slow it down, okay, using certain materials. So how does it work? Well, first of all, when we've got an ice cube and it's sat on a table, the surrounding, my house isn't very warm. I know some of you, your houses were like 20 degrees Celsius. Mine is about 11 or 12 or 13 degrees Celsius. So the surrounding is 12 degrees Celsius. The ice cube is 4 degrees Celsius, or thereabouts, or between 0 and 4, depending on how you want to measure it. Okay, and because this is hot and this is cold, heat goes towards the ice, and then the ice starts to melt. It changes from solid into liquid. It melts. Okay, so this is what it looks like at the start. This is what it looks like at the end. Here it's a solid, and some of the solid has changed into liquid. So we're going to do an experiment to see how we can slow down the ice melting. Okay, so what we need for today, I'm going to put in the video as well, is you're going to need some ice cubes, and hopefully you've got the ice cubes ready. You need about 3 glasses. Okay, these glasses are perfect because they're sort of wide at the top and narrow at the bottom. I don't have these glasses, but anyway. And then you've got to choose any of these 3 materials. So cotton, bubble wrap, aluminium foil, sponge, newspaper, or plastic. You must choose 3. And I've actually got tissue paper. You can use tissue paper as well. Alright, so I'm going to show you a video of me doing the experiment, or explaining how to do the experiment. And you will also possibly need, I have a picture here of some materials that you can use as well. Okay, so here it is. And you may or may not need these materials. You need a timer to time how long it's taken, to time the experiment. You need a ruler to make sure that your material is the same size. You want to use the same size material. A little bit difficult when you've got cotton and things like that. You can see what they did here is they didn't use glasses, they used these plastic containers where the ice melts. So again, you could use that, it's up to you. But anyway, and some sticky tape, but you don't need this. The materials I've given you is all you need. Hi Group A. Today what we're going to do is I'm going to try and do an experiment which probably we might repeat next week when we're back at the Grange. We might try to do this experiment again. I hope you can see me. I think you can. So the idea is, what we're going to do is we're going to take an ice cube. Okay, so I've asked all of you to get some ice cubes ready for this experiment. But if you don't have it ready for today, it is fine. It's not a problem. So I've got some ice cubes, which I'm going to look at in a second. And the idea is that if I take an ice cube and I were to put it on the table, and I leave it for 10-15 minutes, what's going to happen is the ice cube is cold, maybe 0 degrees Celsius, or between 0 and 4, and the room is warm or hot, okay?
And what's going to happen is the heat is going to go from the room, the surroundings, and the heat is going to go towards the ice. It's going to melt the ice, and the ice is going to slowly change into liquid. Okay, so the idea is in this experiment to find out what material can you use to slow down how fast the ice is melting. We'll try and slow it down a bit. Okay, so you had to choose 3 materials. I've chosen my 3. I've chosen bubble wrap. Okay, I've chosen some tissue paper. You can use newspaper, whatever you want, whatever materials you decided to do. And I'm just going to do those 2, but you've got to do 3. And you've got to have 3 containers in which you're going to put your ice cubes. Okay, now my containers are quite big. Now, big is good in the sense that it's easier to put your hand in to take things out. But the problem is you probably need more than 1 ice cube. So you probably need 2 or 3 ice cubes that you're going to put in here. Okay, so the plan is this. You're going to take your material and you're going to decide how big it is, because it depends on the size of your glass and depends on how many ice cubes you use, will depend on the size. Now I think this one is too big, so I'm just going to make it smaller. Okay, so I'm just cutting it quickly. And again, it's up to you how big you want it to be. Okay, so let me just demonstrate quickly what you're going to do and then we will do it. So the idea is you take your ice cube, you're going to wrap it inside your bubble wrap. Okay, and you need to decide how to do it, but I'm probably going to fold it this way and I'm going to fold it. Okay, and the reason why I'm doing it this way is probably because what I'm going to do is I'm going to, let's do that and let's do that, is that when I put this in my glass, okay, I'm going to leave it. Now I need to make sure I do it quite quickly, because this one and the other one I need to do quite quickly. I need to do them together. So okay, so here I've got my ice cubes. All right, so let's get started. So I'm going to take my ice cube, I'm going to take my second ice cube, and we are going to wrap it. Okay, not as easy as I thought. I'm going to try and wrap it. Okay, wrap it. I'm going to put it in here, like that. Okay, and I'm going to do the same with the other paper, or with the tissue paper. You can really see it started melting a little bit. And again, I'm going to wrap it. I'll wrap it like that. And again, I'm going to put it inside my container. Now, like I said, you may have to, after this experiment, I'll be able to tell you whether you need to take maybe 3 ice cubes or maybe more. Okay, but I think 3 should be maximum. But I've taken 2 ice cubes, I'll put it in, and I'm going to leave it. It's not very warm tonight, so I'm going to maybe try and put it near a radiator. Don't make it too hot, because then it'll melt too quickly. So I'm going to time this now, and we're going to say I'm going to leave it for, let's say, 10 minutes, and then we're going to check and see whether there has been any melting. Okay, and I'll come back. Okay, so 10 minutes are now up. Okay, and what I did was I opened up my ice cube, and I did it very, very carefully, because remember, if there is water, we want the water inside the glass. We've got to be very careful when we open it up. Okay, so when you wrap it, also think about how wrapping it. So I'm going to open this up, and I can already tell, because the paper, if you look at the paper, there's no water on the paper. There's no water at all. So it's not melted, and that's 10 minutes. So both materials are actually doing pretty well stopping the ice from melting. I can see there's a little bit of water, but very, very little. So I can actually leave this again. So I'm going to wrap it up again, okay? And I'm going to leave it. And I think what's going to be best is that when you do this experiment, try to have, so you've got your 3 materials, okay? Try to have maybe a 4th glass, but it doesn't matter. The 4th glass, you can just put some ice in. You can check that one. So you don't have to keep checking these, because opening it up and closing it will affect the experiment. So have a 4th glass. Doesn't matter the size of the glass or anything. It takes the same amount of ice. So I took 2 ice cubes. So you take 2 ice cubes, put it inside the material, and then put it separate. And then check that one. Open it up every 10 minutes to see how much has melted. And when you look at that one, you see half the ice cubes have melted away. Then maybe stop the experiment. Again, time how long that takes, and then you can use that time as part of your result. But I'm not going to keep opening this every 10 minutes, so I'm going to make a separate one on the side, which I can open that one every 10 minutes. Okay, so I shouldn't be opening these really. but getting the timing right is quite difficult. Okay, so it's now an hour and 40 minutes later, an hour and 40 minutes, and this one has melted. There's a little bit of a small ice cube in there, tiny little ice cube. I think you can see it, it's floating around there. So let's have a quick look at our ice. Okay, and I'm going to drop this one in. Oh wow, okay, that's a pretty good result. So there we've got, finding the fridge is switched off, lots of noise from it. Okay, and we can see some ice cubes in there. I'm going to take a picture of that in a second. And I'm going to take this one out. And remember what I said with this one, we have to squeeze the water out, but to be honest, what we've got to look at is the size of the ice cubes. Okay, the size of the ice cubes, because we're not going to get the water squeezed out. We'll get some out. Actually, we've got nothing out because the paper is too thick, you can see. So the best thing to do is to compare the size of the ice cubes. Okay, so let's take a quick look. So if we have a look at the ice cubes, you can see this is the one for the bubble wrap, and you can see that the ice cubes are actually smaller than this one. Okay, you can see the ice cubes are smaller. So my conclusion is that if I had to compare the paper with the bubble wrap, the paper did better at stopping the ice melting. Okay, so have a look at your results. Like I said, this has taken an hour and a half, okay, to get these results. So I think an hour and a half is a good time to leave it if you have 2 ice cubes. Maybe a little bit less than an hour and a half if you're using 1 ice cube. And if you use 3, maybe a bit longer, but an hour and a half is what it took me. Okay, so hopefully that makes sense. And if you do this experiment, that'll be great. Take some pictures with Seesaw, or ask mom and dad to take pictures with their phone, and then you can upload it into Seesaw.